Welcome to Probability and Statistics. In this lecture video, we're going to continue with chapter 4.5. This is part 2. Alright, let's continue what we were doing from the last lecture video. So, this problem from the handout says Lori is planning a bridal shower for her best friend. At the party, she wants to serve 3 beverages, 2 appetizers, and 2 desserts. But she does not have time to cook, so she can choose from 18 bottled drinks, 8 frozen appetizers, and 5 prepared desserts at a supermarket. So, in how many different ways can Lori pick the food and drink served at the bridal shower? So, we're gonna pick 3 different things. Okay, she wants to do beverage, appetizers, and 2 desserts. All right. So, from the supermarket, she can choose from 18, 8, and 5. Okay, so one task followed by the other, we will multiply. Now, here we're going to use combination is because the fact that, once she laid the 3 things on the table, it does not really matter whether she have beverage first, dessert first, or appetizer first. Okay, it does not really matter. The problem never say the first thing got to be the beverage. The second thing got to be the dessert. Okay, so then we're gonna use combination. Now we got 18 beverage from the store she can choose from. All right, using combination for any 3 beverages. Okay, it does not matter which one, the order of which beverage she choose from. Out of the 18 does not really matter. When she bought the stuff and take it to the party, which one she placed does not matter either. Which one where did she place what food does not really matter. Alright, so that's beverage. Let's do the appetizer. She got 8 frozen appetizers to choose from. Choosing 2 of them using combination. 5 prepared dessert, choosing 2 of them. Alright, if you type this in and multiply them, the answer will be 228480. So this will be how many different ways she can pick the 3 things. Alright, so this is just a combination problem. Alright, this problem right here, I think we talked about something like this before, a little bit about songs. Alright, so let's say DJ Sam is making a playlist. He's trying to decide what 9 songs to play and in what order they should play. Alright, so if he has his choice narrowed down to 24 reggae, 24 jazz, and 14 pop, and he wants to play an equal number of reggae, jazz, and pop songs. So how many different playlists are possible? So first thing first, okay, he wants to play equal number of these 3 types. So that means 3 songs each. Okay, so 24 reggae, choosing any 3 of those. Okay, doesn't matter which one, the order which one he choose from the 24 reggae does not really matter, because we need to see how many different 3 songs he need to pick. Followed by 24 jazz, when we're choosing 3 of those again. Followed by 14 pop songs, she's choosing 3 of them. Okay, so this will be the songs. Okay, excuse me. This will be the 3 songs from each type. Okay, that he can choose from. But now the problem does say he's trying to decide what 9 songs to play and in what order they should be playing. So that means once he chooses the individual type, then he got to put them in order. So that means the order of which one of these, these 9 he played first does matter. So that means we have to multiply. We got to take all these number of different ways he can choose the songs from each type. Then we got to multiply by, there are 9 songs total, choosing all 9 of them, play all 9 of them using permutation. Because he's trying to, because once he choose individual type, then the order become matters, out of the one he choose, which one to play first. Okay. And write your answer as scientific notation. So that means this is a big old answer here. So 24 choosing 3 times 24 choosing 3 times 14 choosing 3 and times by 9 songs he ended up picking from each group, choosing all 9 of them to play using permutation. Oops, sorry. Choosing 14 choosing 3, I forgot. Right there. Okay. Alright. Round to the 100th place. So I need the 100th. Write as scientific notation. So that will be this one. 5.4, 1 times 10 to the 14th power. Okay, that would be my answer. 10 to the 14th power. Okay. Alright, so that would be my answer. That would be that many ways. Okay. So the problem goes like this. Okay, you got 24 records he can choose from. He need to choose 3 of them. The order which one he choose first one of those 24 does not matter. So that's why we use combination. Okay, so once he select 3 songs from each group, okay, we get a lot of ways from here. Then out of all those ways, okay, which one he gonna choose to play first for the 9 songs does matter, because in what order they should be played. So that's why we added a permutation, okay, at the very end. So that'll give me this many ways. Alright, so let's toss some coins again, and this time this problem is a little bit bigger coin tossing problem. Alright, toss a coin 11 times, so the number of heads is between 5 and 10. Alright, check it out. We want heads, so what we can have is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 11 heads. This problem wants me to have 5 and 10, between 5 and 10 inclusive. So what I want is 5 all the way up to 10. So other ways is what I don't want. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what I want, what I don't want is a semi-equal amount of scenarios. So it does not really matter which way we attack. But I'm gonna go from I'm gonna just go from directly what I want. Alright, so let's do the 5. Getting 5 head scenario. 11 coin, 11 toss, choosing 5 on our head. Or, this is or because this go by scenarios. Or I can do 11 choosing 6 hand, or 11 choosing 7 hand. Or 11 choosing 8 hand plus 11 choosing 9, or 11 choosing 10 hands. Okay, these are my possible scenarios. Alright, so let's do each one and figure out. So we can type all this in together, or we can just do it separately. I'm going to do 11 choosing 5 first and give me 462 right here. 462. Then we'll begin to add. Because now in my calculator I can do second entry and change the 5 to a 6. 462 again. Plus 11 choosing 7. So either way, you can type it all in at one time, or you can type it separately like the way I do. It does not really matter. 11 choosing 8. There's 165 ways. 160 what? 8 ways? 65. Okay. Plus 11 choosing 9 heads. 55 plus 11 choosing 10 heads. 11 ways. Okay. Alright, add them all up. 462 plus 462 plus 330 plus 165. 55 and 11. 1485. There are 1,485 ways we can get different heads, between 5 to 10 heads inclusive. Alright. Alright, let's do another type of problem. I don't think I introduced this one. Well, this is a lot like other combination we do. A certain congressional committee consists of 12 senators and 9 representatives. How many ways can such a subcommittee of 6 people be formed if at least 4 of them, okay, of the member got to be the representative? Or at least 4 got to be the representative of the 6. So our possible scenario is having 0 representative, 1, 2, 3, 4, 5, all the way up to 6, because this subcommittee has 6 people. At least 4 member. That means what I want is 4 all the way up to 6. This is what I want. Okay. Alright, so let's do, so I'm going to attack this directly, because what I don't want is more ways than what I want. So let's do 4. Think about this for a minute. If 4 of them got to be representative, that means the other 2 got to be the senators. Or I can have 5 representatives. That means the other 1 person got to be senator. Or I can have all 6 of them are representative. That means there's no senators on this subcommittee. So these are the 3 possible scenarios. So how many ways I can choose 4 representatives and 2 senators? Alright, there are 9 representatives. I'm going to choose 4 of them, followed by 12 senators, choosing 2 of them, plus 9 representatives, choosing 5 of them, followed by 12 senators, choosing 1 of them on the subcommittee. Or I'm going to do 9 representatives to choose from, choosing all 6 of them, followed by 12 senators, choosing none of them. Okay. Alright, so these are the scenarios. So the plus sign matching up with the plus sign. Okay. Alright, so let's type this in. I'm going to do it separately again. I'm going to do 9 choosing 4 times 12 choosing 2. 16632. 9 choosing 4, followed by 12 choosing 2. Senators. Let me see, I'm gonna make sure I'm doing it right. Oh Lord, typing it wrong. I'm typing a permutation there. Ooh, I'm sorry. I'm about to say why the number's so big. Alright, let me fix that real quick. There we go. 8316. 8316. Alright, so plus 9 choosing 5. So I'm gonna come over here and the second entry, choosing making the 4 to a 5, and making that last 2 to be a 1. That gives me 15, 12 different ways, plus 9 choosing 6, and the last one is 0. Tallest integer choosing none of them, 84 ways. Alright, add them up, 8316 plus 1512 plus 84. So that'll give me 9,912 ways. Okay, to select at least 4 members. Must be representative. Alrighty. Alright, let's do another movie questions. So this is a slightly different scenario. So I don't really know how to say this one. Giovanni is picking out some movies to rent, and he has narrowed down to his selection to 5 comedy, 6 children, 4 drama, and 5 mystery. So how many different combination of 9 movies? So we want 9 movies. Can he rent if he wants all 6 children's movie? So this is a little bit different scenario, because all he wants is having all 6 children movie. Alright, other than 9. So he wants 6 children, but the problem does not say rest of the movie. Okay, gotta be what? So we know we got 3 left. We know we got 3 movies left for other type. So this is basically thinking that 6 children and how many of other ones? Well, how many other ones are there? 5 comedies plus 4 drama plus 5 mystery. There are 14 other ones. Okay, so 6 children, so that means we will end up with 3 other ones. Okay, so we got 6 total children movie. I'm going to choose all 6 of them, followed by there are 14 other movies total. I'm only going to choose the other 3, so that makes them 9. 6 plus 3 makes that 9. And that's all there is to it. Okay, since he wants this all children's movie, that means everybody else is going to be the 14 choosing 3. So if you put this in calculator, that will give you 364 ways to choose. Alright. Alright, so this one's not that bad. Alright, let's try this one. In business class, there are 15 men, 14 women. 4 students are randomly selected to present a topic. What is the probability that at least 3 of the 4 selected are male? Okay, so that word at least, okay, give me the hint of I got this thing. Okay, my scenarios got to be 0 male, 1, 2, 3, all the way up to 4, because I'm only gonna have 4 students being selected males. At least 3 are male, so that means 3 and more. So that's 3 and 4 is what I want. Okay, so let's just think about 3 males. If 3 of them are male, that means the other 1 student's got to be females. Or I can have 4 males. That means I will end up choosing 0 females. Okay, so that's my scenarios. Okay, so I'm gonna put it right here. So this problem is asking what is a probability of at least 3 males. So that will equal to how many ways I can select 3 males out of my total possible outcome. My total possible outcome got to be there are 29 students. I'm only going to choose 4 of them. Okay, so that will be my total possible outcome of all possible scenarios together. 3 male, 1 female. That scenario. So that will be 15 male choosing 3 of them, followed by 14 female choosing 1 of them, or means we will add. I'm gonna put this in the parenthesis so you can see this is one scenario, or I can have 15 male choosing all 4 of them, followed by 14 female choosing none of them. Okay, so that's my possible scenario. That'll give me the number of ways for what I want out of my total possible scenario down here. So if you put the top in the calculator, I believe you should come up with 7735 for the top. The bottom, 29 choosing 4. Okay, 23751. So let's put this in the calculator again and divide it and see what we simplify down to. So that means the top, just that, these two scenarios together is 7,735 ways. 23751. So you can do fraction answers, or you can do simplified fraction. 85 over 261. Okay. That will be your answer. Okay, that's not too bad. Alright, the next question is a little bit more difficult. Okay, this is a lot like the songs and the problem that we done before about the boys and the girls, girls and the boys, similar to that. So a baseball coach needs to choose 9 players to be in the batting lineup for the next game. There are 4 freshmen, 4 sophomore, 5 junior, and 4 senior on the team. How many ways can the batting order be chosen if the coach wants no more than 2 juniors to be in the lineup? No more than 2. Alright, so let's think about the scenario. Juniors, there are 5 of them, so the coach can pick 0 junior, 1, 2, 3, 4, all the way up to 5 juniors. No more than 2. No more than 2 means what I want is 0 and 1. Excuse me, 0 all the way up to 2. No more than 2. So that don't want to be 2 or higher. Okay, so there's 3 scenarios. Well, in that case, let's think about this. No more than 2. So what happens if so that means a coach can choose 0 junior. Well, what about the other 9 players that's supposed to be in the lineup? The other 9 players got to be all the other ones. So I'm gonna say 9 other players gonna be other. Or I can have 1 junior. That means other 8 position will be others. Or I can have selecting 2 juniors, so that means 7 other players on the lineup are other grade. Okay, so these are my scenarios. Okay, so how many lineup can it be? Alright, so let's say we got 5 juniors I'm going to end up choosing none of them, followed by multiply. Then I'm going to choose the other 9 players from other ones. So what's other ones together? Other ones are 4 freshmen, 4 sophomores, 4 seniors. So that's the other 12 players on the team. I'm going to choose 9 of them to be in the lineup. Or 5 juniors, choosing 1, followed by the other 12 players, choosing for 8 other position, followed by 5 juniors, choosing 2, followed by the other 12 players on the team. This time I'm going to choose 7 of them. Okay. Alright, so that will be the people, that will be the player I will choose. Okay, that will be the scenarios that I choose. Okay, 0 junior, 1 or 2. So once I choose no more than 2 juniors, so that means I got my lineup ready. Then we gotta think about the batting order. Who bat first? Who bat second? Who bat third? Matters. So this is just like the song question we did in the last video. So now I'm going to play all 9 players. So that will be followed by 9 players choosing all 9 of them using permutation. Because who bat first actually matters. Okay. So just like the song, the reggae, the jazz problem. Okay. We make our selection from each scenario. Then once I select them, then which one could go batting first matters. So I'm going to type all this in together. 5 choosing 0 times 12 choosing 9 plus 5 choosing 1 choosing 8 plus 5 choosing 2 times 12 choosing 7 close parenthesis times 9 choosing 9 using permutation. That'll be this. 3851971200. Okay, so this problem wants me to write the answer in scientific notation. Okay, I'm writing scientific notation. So my decimal, so I got to move my decimals where right now it's behind the last 0. I got to move it between the 3 and 8. Because scientific notation, the first number is between 1 to 10. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9 places I gotta move. So round to nearest 100. So that'll be 3.85 times 10 to the 9 power. Okay, that'll be my answer. All right. Alright, next, step number 2. Okay, this is a little bit different. So, same thing, 9 players, 4, 4, 5, and 4 on the team. How many ways can the batting order be chosen if a coach wants all 4 sophomores to be in the lineup? Okay, so earlier we had to choose. I got 5 junior. I want to choose 0, 1, or 2. This time, they want all 4 sophomore. Alright, so same idea, but slightly different scenario, because right now, if I'm going to choose all 4 of my sophomore, that means the other 5 spots in the lineup going to be others. And that's the only scenario I can have. And that's the difference between step 1 and step 2. Okay. But this time, See, the coach can selecting 0 sophomore, 1, 2, 3, all the way up to 4 sophomores. But this time the coach want all 4 sophomores to be on the lineup. So that means this is only a 1 scenario problem. So 4 sophomore, the other 5 positions gotta be others. Alright. So that being said, 4 sophomore choosing all 4 of them, followed by, alright, so 4 plus 4 is 8 plus 5 is 13. So there are 13 other players on the team. It's gonna choosing for 5 slots in the batting lineup. So once I figure out how many ways I can choose 4 sophomore and 5 other positions, now the batting lineup will be 9 permutation 9. And if you put this in a calculator, I believe the answer will be 467026560. And if we write it down as a scientific notation, where the decimal going to be between the 4 and 6, that will give me 4.67 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That will be to the 8 power. Okay. All right. Let's take a look at the delegation problem. How many ways can a delegation, 3 Republican, 4 Democrat, and 2 Independent, be selected from a group of 9, 6, and 4 Independent? So this problem is a lot like the bridal shower problem. Okay, just a combination problem. So I'm gonna skip over this one. Go to the next one. All right. So this is the movie problem again. Alright, but this problem is a little bit different, okay? So we're narrowing down to 12 documentary, 19 mystery. How many different combinations of 4 movies can he rent? So it's just asking for, if I want to pick 4 movies, how many different combinations of any 4 out of the 12 and 9 documentary and mystery? So 12 plus 9, that means we got 31 movies to choose from. I want to choose 4 of them, okay, using combination. The problem does not say which one I got to pick first. So 31 choosing 4, that will give me 31,465 different combinations. So this number will be the total number of ways, okay, we can select 4 movies. So now, same thing, except this time it's saying how many different combinations of 4 movies can he rent if he want at least 1 documentary. Alright, so that means he can choose 0 documentary, 1, 2, 3, all the way up to 12 of them. Okay. So what he wants is at least 1, so that means 1 all the way up to 12, and that's a lot of scenarios. So this problem will be easier if I can figure out what he does not want, then subtract it from the total 31,400. Alright, so think about this. If he does not want 0 documentary, so that means the other 4 movies got to be the mysteries. Okay, hope that makes sense, because he only want to rent 4 movies total. Alright, so this is what I don't want, so we take what we want, which is all this, right, minus what I don't want, which is 12 documentary, end up choosing none of them, followed by 19 mystery, because there's only 2 things going on here, documentary and mystery, choosing 4 of them. Okay, so if you type the second part in the calculator and subtract, I believe the answer will be 27,489 ways we can pick at least one documentary. So that will be the total number of ways from 1 through 12, except 0. Alright. Alright, this one is pretty interesting. 5 cards are drawn from a standard deck without replacement. What is the probability that at least one of the cards drawn is a diamond? From the probability of at least one diamond. Alright, at least one diamond. So again, we're gonna draw 5 cards. We want to draw at least one diamond. So that would be, I can choose 0 diamond, 1 diamond, 2 diamond, 3 diamonds, 4 diamonds. Okay. I can choose all 5 cards could be diamond. Alright. I want at least one of them is diamond on the 5 card. So all the 5 card I drew, I could actually have 0 diamond, 1 diamond, 2, 3, or all 5 of them can be diamonds. Alright, so what we want is 1 all the way to 5. So what we don't want is end up with no diamonds. So we can figure out what we don't want. Subtract it from 100%, so that will be 1 minus the probability of selecting 0 diamonds. Alright. So that will be 1 minus. Alright. How many ways I can choose 0 diamonds? 0 diamond. What's another way of saying 0 diamonds? 0 diamonds means no diamonds. No diamonds means the other cards are not diamonds. How many other cards are not diamonds? Remember, there are 52 cards in the standard deck minus all the diamonds, which is 13 cards. So that means there are 39 other cards that are not diamond. And I'm going to end up choosing all 5 of those other cards are not going to be diamond. Because 0 diamond means all 5 cards are other than diamonds. So there will be 39 other cards, choosing all 5 of them. Out of 52 cards to choose from, and I'm choosing 5 cards total. So there will be 52 choosing 5. Using combination, because once again, once you draw 5 cards, the order which one you draw does not really matter. So I'm going to put this in the calculator one time. This is going to be 1 minus. You know what? I'm going to do this separate. I'm going to do the 30. I'm going to do the 39 choosing 5 first on top. 39 choosing 5. Close parenthesis divided by 52. Sorry. Tapping around. Parenthesis 52 choosing 5, so that will give me that 1 minus second A and S, answer from the previous line. So that would be 7,411 out of 9520. I can run 4 decimal places, 0.7785. Okay, either way will work. Alright, so this problem, selecting what I don't want is end up with 0 diamond. So another way of saying 0 diamond is by saying all the 5 cards I have in my hand are not going to be diamond. So that's everybody else other than diamond. So everybody else are 39 cards are not diamond, choosing all 5 of them. So that will give me so many ways on 0 diamond. Alright. This piece of question is the same as the bridal shower again. Okay. So how many different supreme choice of pizza can be made? So if I do this one real quick, 2 different meats, 4 different vegetables, the customer can select one of the 4 types of crust. If there are 4 meats, 8 vegetables to choose from, how many different supreme choice of pizza can be made? Alright, so we got 4 meats, choosing 2 of them, followed by 8 vegetables. I'm going to choose 4 different types. And once you put them all on the pizza, you cannot really tell which one you put first. So the order which one I put first does not matter, so we use combination. Followed by selecting one of the 4 crusts, so there's 4 choosing 1. If you put in the calculator, that means you can make 1,680 different supreme pizza. Alright, I'm gonna end this lecture video with this problem. Very interesting problem. In a certain shipment of 13 phones, 4 of them are defective. 4 of them don't work. Alright, so out of the 13 phones in the shipment, we can select 11 of them without replacement. So, what is the probability that 4 of the 11 phones are defective? Okay, very interesting. So, let me write the problem down. What is the probability of 4 of the 11 phones that are defective? Okay, so this problem is a bit tricky because out of the 13 phones, 4 of them are defective. So, and I'm selecting 11 phones. So out of the 11 phones, I can select none of them are defective, 1 defective, 2 defective, 3 defective, 4 defective, and that's all I can choose from. Okay? Because there's only 4 defective after all. So they want us to find 4 defective. Okay, so this is the only scenario I want. So if you think about this scenario, if the 4 are defective, that means out of the 11 phones I'm gonna select, 4 are defective. That means the other 7 is not defective. Okay, so that's a scenario. Alright, so that being said, 4 defective, there's only 4 defective total, so 4 defective phone total, choosing all 4 of them, followed by, well, I'm going to choose 7 that are not defective, but how many do I choose from? How many phones do I choose from? If I'm going to select, I know if I'm going to select 11 phones, 4 are defective, 7 are not defective. That's what I want to choose. But how many other defective are, how many other phones are not defective? So that's where the 13 come back in again. If there are 13 phones total in the shipment, 4 are defective, that means I tell you that there are 9 is not defective. So I got 9 phones that are not defective total, choosing 7 of them for this scenario. Okay. So that would be how many ways to choose 4 defective phones. Alright. So what's my total possible outcome? Well, there are 13 phones total, and I'm going to select 11 of them. Doesn't matter whether it's defective or not defective. Okay. So when you put that in the calculator, you go to 4 decimal place, that will be 0.4615. About 46.15% chance that we're going to select 4 of them that are defective. Okay. Alright, so thank you. This will conclude our video. our lecture video. Thank you for watching.